Hello, my everybody's. So I took a poll recently, and people were pretty even on whether they wanted to see something science related or something futurism related. So I'll do both. The problem that most people have with science, as far as understanding, is they don't understand the true scales of things. It's a lot bigger than people think. Let's start with one of the smallest structures, the atom. An atom is about 1 billionth of a meter. If you're not sure what that means, you know how much a thousand is, right? So 1,000 thousands is 1 million, and 1,000 millions is a billion. So within that 3 feet, I'm holding my hands up, but you can't see it, you will have about 1 billion subdivisions of length. Um, Basically, that's pretty damn small. And even further down, if you look at the size of the full atom compared to just the nucleus is a factor of 10,000 times smaller than the atom itself. That's like putting a pea in the middle of a NASCAR racetrack. Uh, all of that is empty space where the electron shell is. If you don't know what the electron shell is, basically it's where the electron is most likely to be in the atom. There's it's kind of a fuzzy thing, but basically you can think of it like a cloud where the electron might be. But that's a factor of 10,000 times smaller than that even. Okay, let's bump it up a few notches. The Earth is 12 million times longer than a meter if you just take the diameter. That is, 3 feet. You know how big that is. Well, the Earth is about 12 million times bigger than that. Um, that's pretty big, right? When uh, when you look at the type of scale, it kind of puts things into a better perspective. Once you start knowing these sizes, you can calculate, for example, how many atoms are in the Earth based on those numbers. If you want to do that, that's some extra credit for you. But then the solar system in which you live, all the planets from the Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and all the minor planets like Pluto, Ceres, and Sedna, all those others, that is 287 billion kilometers. That's 287 trillion meters. That is a factor of, another billion, 287 billion, bigger than that. So, I mean, we're looking at enormous, enormous sizes. The speed of light is only 300,000 kilometers per second. That's 3 million meters per second. At that distance, light can go around the Earth only 7 times. It takes 8 minutes for the light to go from the sun to the Earth. So for light to get from the Earth to Mars, or vice versa, and it's when Mars and Earth are kind of in its closest orbits, when they're kind of like right next to each other, it would take 3 minutes for light to get from one to the next. At its farthest, when Mars is on the other side of the sun from the Earth, it takes a whole 22 minutes. That's pretty far already. Um, Next, we look at scales too. That's not even a light year. A light year is the distance that it would take light to travel a full year. 1 light year is about 9.5 trillion meters. That's 9.5 billion kilometers, or in terms of miles, about 5.9 billion miles. So, yeah, a light year is pretty long. The closest star to us is 4 light years away. And the galaxy, our galaxy, the Milky Way, about 105,000 light years across. So the sizes here are crazy. If you shined a laser from one end of the galaxy, it wouldn't get there for 100,000 plus years. That's pretty nuts. The distance to Andromeda, which is kind of the nearest good sized galaxy, is about 2.5 million light years away. That's about 250 galaxies width. Just a stone's throw away, right? Yeah, and the numbers just keep going up and up and up to scales that humans really cannot realistically conceive. Um, Even if you think you understand the sizes and the scales, the only way you can really wrap your mind around it is through metaphors of, like I said, the P in the racetrack when comparing the size of the nucleus of an atom compared to the atom itself. It is mind-bogglingly huge, and yeah, things like Star Trek and all these other things, without complete rewrites of the laws of physics, it ain't happening anytime soon. Nothing like a warp drive exists. We don't really know how that sort of things would happen, even if we did go faster than the speed of light. We couldn't go faster, but if we even went at the speed of light, you'd suffer from problems like time dilation, where the people that are going faster would experience time, almost no time would pass, whereas back on Earth or where everything is still, they would they would be they can fast forward compared to the person that's in the ship going 1,000,000 miles an hour, or a light speed. Um, Light speed is actually faster than 1,000,000 miles an hour. But regardless, um, we're nowhere near getting to light speed in what we've done so far. Nowhere near. So, yeah. Does the whole scale of things make your brain hurt yet? It does for most people. If you have any questions about anything here, or if you have your own questions about really anything in the science world, or in the futurism world, or anything really, let me know either here on YouTube or on TikTok, and I will get back to you and put a video together. I'll see you later.